Good morning, it's the third day of forces here on your Physics 5 a day, and I'm going to start working through the types of force that you need to know about, just saying a few brief words about them. So first up is weight, which is what we usually call the force due to gravity. Now, all objects with mass exert gravitational forces on all other objects with mass. So the Earth exerts a gravitational force on my pen, and the pen exerts a gravitational force back on the Earth. But I also exert a gravitational force on my pen, and the pen exerts a gravitational force back on me. The difference though, the important difference, is the size of these forces. So because the Earth's mass is so huge, the force that the Earth exerts on the pen is actually noticeable, whereas the force exerted by me on the pen is negligible. Okay, and so the things you need to know about weight are that it's obviously equal to mg on the surface of the Earth, and for all of our calculations we'll be using g is 9.81 newtons per kilogram, which is equivalent to 9.81 meters per second squared. And also it acts on the centre of gravity of an object. For a person, that's just about your belly button. So you start your weight arrow from the centre of gravity, and then it goes vertically downwards. You will see it written, and people will say that weight acts on the centre of mass of an object. So long as your gravitational field is uniform, these two are the same. And when you're doing experiments in the lab, when you're building bridges, anything on the surface of the Earth, then they are effectively the same. The next force is tension, which is any contact pull. The important thing to say about tension is that it is transmitted along a cord. So a rope, it doesn't have to be flexible, so you can pull a stick, but whatever it is, tension is transmitted along it. So let's say in this example that the tension in the string is 5 newtons. What we're saying is that if you were to insert a Newton meter anywhere in this string, so at any point in the string you cut it and put a little Newton meter in, anywhere that you put it, it would read 5 newtons. And if we imagine that the string is made of lots of tiny little bits of string, then you can think of each one as pulling on the next one, which pulls back, which pulls on the next one, which pulls back, and so on. And that's how come you've got your 5 newtons pulling to the right here and pulling on the car, but pulling upwards on the mass hanger. If you're wondering what's going on with the pulley in the change of direction, remember the pulley is also exerting a force on the string there. The last force I'm going to talk about in this video is friction. So here I've got a block on a slope. If this block is sliding down the slope, so they're in contact and the block is sliding down the slope, then the block and the slope are going to exert moving friction forces on each other. However, if the block is stationary, resting on the slope, not moving, the block and the slope will still exert friction forces on each other, and those we call static friction. You probably instinctively know that static friction forces are bigger than moving friction forces between the same objects, because when you try to push something, so say you've got like a big heavy wardrobe on a carpet or something like that, when you go to push it, it's more difficult to get it moving. Once it's moving, it moves easier, but getting it moving is more difficult. And that's because the static friction when the wardrobe's stationary is bigger than the moving friction when the wardrobe's got going. So in simple terms, I usually think of it like this. Moving friction is when two objects are touching and sliding past each other, and static friction is when two objects are touching and trying to slide past each other. I know that's not very scientific, but that's kind of how I think of it. This block is trying to slide down the slope. Now, strangely, your A-levels don't expect you to know the difference between these two. I find that strange because it's pretty obvious as soon as you look at an example. They also don't require you to know the formula for the size, but many of you will have seen it in further maths. So the friction force is usually given as being equal to some constant, the coefficient of friction for those two surfaces, times the normal contact force that they're exerting on each other. And don't forget that if your object is moving through a fluid, for example water, then you're going to call the friction force drag. And if your object is moving through air, you can call it air resistance.